friends, last we discussed about the numerical of exercise and illustration till the one illustration 10.8 is remaining. Okay, before starting our discussion about the illustration 10.8, now one more important application is that we are going to prove so that when the unpolarized light is incident on a polarizer, then the intensity of the emerging light from the polarizer is half of the intensity of the incident light. We have to prove this thing. That means the unpolarized light is incident on a tourmaline plate or a thin plastic sheet. So whatever the light is coming out from this plastic sheet or the tourmaline plate, the intensity is half of the intensity of the incident light. We are going to prove this thing. For that purpose, we assume that suppose the intensity of the incident light is I0. Suppose the intensity of light incident on a polarizer is I0 and intensity of light, intensity of emerging light is I. From Ballas law, I is equal to I0 cos square theta. I is equal to I0 cos square theta. Now, the intensity of the emerging light is the average intensity is equal to the average intensity of the incident light between 0 to 2 pi. Why? Because the actually VR, that is the unpolarized light incident on a thin plastic sheet. That is the axis. That is the axis of the polarizer. Now this polarizer is rotated. So each and every time the light emerging out is parallel to the x-axis. Parallel to the x-axis. Therefore, we are rotating this polarizer between during the one rotation, that means the angle theta is equal to 0 to 2 pi. Therefore, we have to take the intensity of the average light is equal to the average intensity between 0 to 2 pi. Therefore, the intensity of emerging light is equal to the average intensity between of incident light between theta is equal to 0 to 2 pi. Then average intensity average I is equal to average I0 cos square theta. I0 is the maximum value of intensity that is constant. Therefore, we take the common I0 average value of cos square theta. But we know that average cos square theta, average value of the cosine function is given by the equation 1 upon 2 pi integration 0 to 2 pi cos square theta into d theta. Here we know that is equal to I0 into 1 upon 2 pi integration 0 to 2 pi cos square theta into d theta. So that is the standard equation. We learned about this equation in AC circuit to find out the average value of electric current. Average value of electric current. Now listen here, cos square theta. So 1 plus cos 2 theta by 2. Therefore is equal to I0 upon 2 pi. I0 upon 2 pi. Now integration 0 to 2 pi. Instead of the cos square theta, 1 plus cos 2 theta by 2 into d theta. Into d theta. This 2 is taken out, therefore I0 upon 4 pi. I0 upon 4 pi. Is equal to I0 upon 4 pi. Now, we apply the separate integration 0 to 2 pi, 1 into d theta plus 0 to 2 pi cos 2 theta into d theta. Therefore, I0 upon 4 pi. Here, integration of this is theta. Raised from 0 to 2 pi plus integration of cos 2 theta, that is the sine 2 theta by 2, sine 2 theta by 2, and its value raised from 0 to 2 pi. We substitute the value of theta, I0 upon 4 pi. First is substituted, theta is 2 pi, then 0 is subtracted. Plus here sine 2 into 2 pi minus sine 0 by 2. So this value is 0, 0. Therefore, I0 upon 4 pi into 2 pi minus 0. Plus these all values are 0. Therefore, I0 upon 4 pi into 2 pi, therefore I0 by 2. Thus, average intensity of the emerging light is the half of the intensity of the incident light. Here is, so that is the, here we are using the trigonometric function and concept of the integration. We can obtain the result again. We have to prove that when the unpolarized light is incident on a polarized, the intensity of emerging light is half of the intensity of incident light. For that purpose, suppose the intensity of incident light is I0 and intensity of the emerging light is I. From Ballard's law, I is equal to I0 cos square theta. This figure is only for our understanding. Okay. Now, the intensity of the emerging light is equal to the average intensity of the incident light between 0 to 2 pi, because we are rotating this polarizer about its axis. During the one rotation, the angle changes from theta is equal to 0 to theta is equal to 2 pi. Now, therefore, the average intensity, average I is equal to average I0 cos square theta. I0 is the maximum value of intensity that is taken out of this average. Therefore, average I is equal to I0 average cos square theta. Now, average cos square theta is 1 upon 2 pi, 0 to 2 pi cos square theta into d theta. Value of this is this value. Now, we also know that the cos square theta is equal to 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. We are using this concept, therefore I 0.2 pi, 0 to 2 pi. 1 plus cos 2 theta by 2 into d theta. We apply the integration to its term, this 2 is taken out, therefore I 0.4 pi. First bracket, here 0 to 2 pi, here 1 into d theta plus 0 to 2 pi cos 2 theta into d theta. Now integration of d theta is only theta, value varies from 0 to 2 pi, plus integration of cos 2 theta is sin 2 theta by 2, value varies from 0 to 2 pi. We substitute I0 upon 4 pi, s theta plus first 2 pi minus 0. So 2 pi minus 0 plus, here sin 2 theta is equal to 2 pi minus sin 0 upon 2. Therefore, I0 upon 4 pi into 2 pi, because the value of sin 4 pi is 0, sin 0 is also 0, therefore I0 upon 4 pi into 2 pi. So here I0 by 2. Thus the intensity of the emerging light is the half of the intensity of incident light. Now illustration number 10.8. Discuss the intensity of the light when the polarizer sheet or the polaroid sheet is placed between the two crossed polarities. Discuss the intensity of transmitted light when a polaroid sheet is placed between two crossed polarities. Here the situation is this way. So what's the arrangement of these polarities? For that purpose, that is the X. First polarity is placed like this way. The axis of the polarity is this. That is our P1 polarity. And its axis is this. That is our axis is A1. Now, third polarity is perpendicular to the axis. Third polarity is placed in such a way that the axis of the third polarity is perpendicular to this. For that purpose here, the third polarity is like this way. That is the axis of third polarity. That is A3. A3 is actually the 90-degree angle with the axis of A1. Theta is equal to 90. There is our P3 polarities. Third polarity, P3. Between these two polarities, we place the one more polarity of the polarizer sheet in such a way that the angle is, and this polarity is also rotating about this axis. For that purpose, the third polarity is placed like this way. There is a second polarity P2. The axis of second polarity is this. It makes the angle with the axis of first sheet is theta 1. So this axis is drawn here. So there is the A2, there is the A1. Angle between the A2 and A3 is pi by 2 minus theta. Pi by 2 minus theta. That is our A2. As shown in figure, a third polarity is placed between the two cross polarities. That's shown in figure. Polarities P1, axis of polarities P1 and P3 are perpendicular to each other. P1 and P3 are perpendicular to each other. Polarities P2 is placed between these two polarities and rotate it. First, here we assume that the angle between the axis A1 and A3 of P1 and P3 is pi by 2. Suppose an angle between axis A1 and A3 of polarities P1 and P3 is theta is equal to pi by 2, and angle between axis A2 and A3 of P2 and P3 is theta is equal to pi by 2 minus theta, or the angle is pi by 2 minus theta. So that is a basic explanation required for this numerical. That is the illustration 10.8. What is given? Discuss the intensity of the transmitted light when a polar sheet is placed between two crossed polarities. That means the two polarities are placed in such a way that the axes are perpendicular to each other. One more polarity is placed between these two polarities. That is our P2. So we have to find out what is the final intensity of the light emerging out of these three polarities. For that purpose, here we consider P1 and P2 placed in such a way that the axes are perpendicular to each other, and the polarity P2 is placed between these two polarities and rotating. This polarity is rotating like this manner about this axis. Suppose an angle between the axis of A1 and A3 of polarities P1 and P3 is theta is equal to pi by 2. And angle between the axis of A2 and A3, this angle, here that is shown like this manner, pi by 2 minus theta. That is the angle between these two. That is the axis F3. So it's pi by 2 minus theta. Clear? Oh. Okay, after assuming that the angle between the A1 and A3 is pi by 2 and the angle between the A2 and A3 is pi by 2 minus theta. Now, if the intensity of the incident light is I0 and light transmitted by the P1 is I1, I1 is also I0. Light transmitted by the second Polaroid is I2. And light, or the intensity of the light transmitted by third Polaroid is I3, or final I. Final I. Here we assume that, suppose, intensity of light transmitted from P1, intensity of light transmitted from P1 is I1. I1 is equal to I0. I0 is intensity of incident light. Intensity of incident light. And from ballast loop, intensity of light transmitted by P2 is I2 is equal to I1 cos square theta. But I1 is equal to I0, so is equal to I0 cos square theta. Then the equation 1. And intensity of light transmitted by P3 is I3, or the I is equal to I2 cos square, angle is pi by 2 minus theta. Because the angle between the axis of P2 and P3 is pi by 2 minus theta. So is equal to I2 sin square theta. Because we know that the cos pi by 2 minus theta is equal to sin theta, and square, therefore sin square theta. Substitute equation 1. Substitute equation 1. Therefore, I is equal to, instead of the I2, I0 cos square theta into sin square theta. So we can write in that form I0 sin theta cos theta whole square. So we convert like this way: 2 sin theta cos theta whole square by 4. Therefore, I0 by 4. Here, 2 sin theta cos theta, sin 2 theta whole square. So it's equal to I0 by 4 sin square 2 sin square 2. That is our I. For maximum intensity of the light, take theta is equal to pi by 4. For maximum intensity, take theta is equal to pi by 4. Therefore, I is equal to I0 by 4 into sin square 2. Theta is pi by 4. Therefore, I0 by 4 sin square pi by 2. Sin pi by 2 1 square of this, that is the 1. Therefore, I0 by 4. That is the intensity of light emerging out from the third polarity. Here this again. So here first we mention the angle between the axis of P1, P2 and P2 and P3. After that, suppose the intensity of light transmitted by P1 is I1 is equal to I0, because the P1 is not rotating. Therefore, whatever the intensity of the light, the same light is transmitted by P1. And I0 is the intensity of incident light. Now, the Malus law. Intensity of the light transmitted by P2, because the P2 is rotating. Therefore, I2 is equal to I1 cos square theta. Theta is the angle between the axis of P1 and axis of P2. So, I0 cos square theta, because the I1 is equal to I0. That's the equation 1. And intensity of the light transmitted by P3 is I is equal to I2 cos square. Pi by 2 minus theta is the angle between the axis A2 and axis A3, this angle. Okay. Now here we know that the cos pi by 2 minus theta is sin theta, and square of this therefore sin square theta. Substitute equation 1 is value of I2, I0 cos square theta. Therefore, I0 cos square theta, sin square theta as it is. I0, now, cos square into sin square theta. We take the square common. Therefore, cos theta, sin theta, or sin theta, cos theta whole square. We know that sin 2 theta is equal to 2 sin theta, cos theta. Therefore, we place the 2 inside the bracket and square of this, therefore, divided by 4. I0 into bracket 2 sin theta cos theta whole square by 4 is equal to I0 by 4 sin 2 theta whole square. And I is equal to I0 by 4 sin square 2 theta. For maximum intensity, take theta is equal to pi by 4. Taking the pi by 4, 4, 2 cancel, therefore pi by 2 is remaining. Sin pi by 2 is 1 and square of this is also 1. Therefore, I is equal to I0 by 4. That means the fourth or the quarter of the intensity of the incident light we obtain as a light transmitted by the third polarity. Okay, now next extra numerical that is asked in March 2013 in board exam, and frequently this type of the numerical is asked. This year it also asked the same numerical. Now in Young's experiment, the distance between the two slits is given 0.05 centimeter. That means the 0.05 centimeter is denoted by small d. And distance between the slit and screen is 1 meter is equal to 100 centimeter. We have to find out the distance between third diode fringes and fifth diode fringes. Wavelength of the light used is 5000 angstrom. 5000 angstrom. Therefore, 5000 into 10⁻⁻8 centimeter is equal to 5 into 10⁻⁻5 centimeter. Now here, voltage is given N is equal to third diode. The distance from the central maxima is x3 and distance from central maxima is x3 and n is equal to fifth diode fringes. Distance from central maximum is x5. Yes, the x5. We have to find out the x5 minus x3. Actually, what's happened here? That is the arrangement of Young's double slit experiment. There is S1, there is S2. Separation between these two is D. Now the screen is placed here. There is the central maxima. There is the first bag, second bag, third bag. N is equal to 1, 2, and N is equal to 3. This distance is x3 from central maximum. Now, there is the first die, second die, third die, fourth die, and fifth die. This side die, this side die fringes. So fifth die is this. That is the x phi distance. X dash phi distance. We have to find out the distance, this distance. We require x phi dash minus x3 we require. For that purpose, for die friends, and die friends, there is the xn d upon capital D is equal to n lambda. For n is equal to third, therefore x3 d upon capital D is equal to 3 lambda. Therefore, x3 is equal to 3 lambda d upon small d. There is equation 1. And for n direct friends, there is the xn dash d upon capital D is equal to 2n minus 1 into lambda by 2 into lambda by 2. N is equal to 50. Therefore, x phi dash d upon capital D is equal to 10 minus 1, 9 lambda by 2. Therefore, x phi dash is equal to 9 lambda capital D upon 2D. Equation 2. Therefore, the distance between third die and fifth die friends is x phi dash minus x3 is equal to 9 lambda d by 2 minus 3 lambda d by d upon 9 by 2, that means the 4.5 minus 3, so 1.5 is remaining. Therefore, 3 by 2 lambda d upon d. Again, 9 by 2, 4.5. 4.5 minus 3. Only the 1.5, that means the 3 by 2 is remaining. Therefore, 3 lambda 5 into 10 is 2 minus 5 d is 100 upon 2 into 0.05. Find out yourself. Find out yourself. There is the important numerical we can calculate by using the condition of the constructive and destructive interference for n die and n die fringes.